Remember, exponential functions don't get them mixed up with rational functions. Although an exponential function has a horizontal asymptote, it only has a horizontal asymptote on one side, right? Whereas rational functions have them on both. What's the difference between an exponential function and a log function? Well, exponential functions have horizontal asymptotes. Log functions have vertical asymptotes. So this would be a log function graph here. So anyway, how do you find the equation? Well, all you have to do is plug in the point. Now, you're going to plug -1, you'll be given a point -1 for x and 1/5 for y. So you plug -1 in for x and 1/5 for y, you get this. When you solve for b, you get the b is 5. So the answer would be y equals 5 to the x. All right, I'll have you guys finish these two. Hit the pause button. Make sure that you have the list of log rules here for this section. All right, so I'd have this handy. There's 9 of them if you want to include all of them. These 9 log rules, and I would also suggest you write them for base E as well, just so you have them handy. So you might want to take note of that. All right, getting back to this then, how do you solve a log E equation? You could raise E to both sides, or you could use the definition of log for this one. I'll let you guys do most of these. You can hit the pause button and check. Let me do D though. How do you solve this one? Well, it's a log, sum of the logs. You can write that as the log of the product, and then you can raise 2 to each side, so you get to this. And then when you solve that quadratic equation, you actually get 2 values. You get x equals 1 or x equals -2. But look, if you plug in -2 into the original equation, it's not defined. This expression is only defined when x is greater than 0. This is only defined when x is greater than -1. So we have to rule this one out. There's only one solution to this equation. Okay, let's see. You can do this one. I'll do this one for you, though. This one is kind of messy. It's an exponential equation. I would take the natural log of both sides, and then I'd move the exponents down and multiply everything out. Then I would get every term that has x in it on one side together, factor out the x, and divide. So that's what I get. Check me on that. Last thing here before we move on is sometimes you can't solve the equation algebraically, and so you should be able to, there might be a problem on the final where you have to solve an equation graphically. You'd enter the left side as y1 and the right side as y2. To find where they intersect, you'd use the intersection feature. So they intersect when x is about 2.56 here. How about this one? Find the inverse function of this. Well, to find the inverse function, you would do it the way we did all the other ones. This is a log function, so the inverse would be an exponential, wouldn't it? So how do you find the inverse? Well, you'd set y instead of f of x, so you'd switch x and y, and then solve for y. Now, in the book, they first solve for x. They actually first solve for x and then switch, but anyway, it doesn't make a difference. I switch x and y, and then I solve for y. From here, I'm gonna raise e to both sides, or you can use the definition of log, and when you solve for y, you get this for your inverse function. I'll let you do this one, because on this one, the domain of the log function, what's inside the log has to be greater than 0, so you would solve this with a sign chart like we did before. We'll do a couple of these application problems now. If you're investing $4,000 at 4% APR, how many years will it take for the investment to worth $8,000? You plug everything in, you're solving for t, right? So I would divide by 4,000, take the natural log of both sides, bring down the exponent when you solve for t, I get this. I'll let you do this one on your own. Hit the pause button and do this on your own. The annual rate of return, I'm going to let you do both of these on your own because we've done these before. Hit the pause button and do 20 and 21. Let's do this one though. 22 says you invest money at 6% APR, compounded monthly. How long will it take for it to double? They don't tell you how much you started with. But if you started with P dollars and you have twice it, you see how the P's cancel? So it turns out it doesn't make any difference. You don't even have to know the initial amount. You can solve for T and you get 11.6 years. This one, we're going to use the exponential growth formula. We first find P0 by plugging in 0. Then you use the information 8 for T and 6,000 for P. And you can solve that for K. Once you find K, you've got the equation. So then you would set the equation equal to 10,000 and solve for T. Radioactive substance, you initially have 50 kilograms, and 80 years later you have 40. So you can use that information to find k. You first find k. Notice k will be negative. Once you get k, you can answer the question. You can set the amount equal to 25 and solve for t. Let me do this last one here. On this one, they're giving you the half-life, and they want you to ask you how much before 20% is left. They don't tell you how much you started with, though. And it turns out it doesn't make any difference. Look, if you started with n0, in a half-life, which is 190 years, you'll have half of that amount, right? So look, if you plug 190 for t, you set n equal to 1/2 n0. N0's cancel, so you can solve and find k. Over here, we actually find k. Where is k? K is right here. Once you get that, you can ask how much before 20% is left. If 20% is left, it's 0.2 n0, and the n0's canceled. You can find t. Okay, last thing. There will be something from 4.7, either with pH or Richter scale or decibel reading. You could either be given the intensity in centimeters and asked to find the Richter scale reading, or you could be given the Richter scale reading and you could ask to find the intensity. Anyway. All right, good luck on the final.